In this video, I'll show you how to integrate using inverse trigonometric substitution. This is question 2 of this series. The function we'll be integrating in this video looks like this. And to integrate this function, we need to use inverse substitution, which is a technique that works well with functions containing radicals found in the denominator, as in the function we have here. And you'll notice that part of our function matches one of these expressions, namely this one, where our a would be 1 minus x squared. And because this part of the function matches this expression, we have to set x to the following. So let's do that for step 1. So in step 1, we are told to set our x value and then subsequently find the derivative. X is equal to 1 sine theta. And of course, we don't need to write this 1 down, that's redundant. And we're going to find the derivative of this equation. The derivative of this equation gives us dx is equal to cosine theta d theta. Step number 2, we substitute this x and the dx back into the original equation. Remember, the original equation looks like this. So we have the integral of 1 over, and remember we set x to sine theta, so this becomes sine squared theta times the square root of 1 minus, and remember we're applying sine into this x, so we end up with sine squared theta again. And of course, our dx has to be replaced with cosine theta d theta. Cosine theta d theta. And since these two parts are being multiplied, this can go up here. Step number 2 is now accomplished. In step number 3, they ask us to use the appropriate trigonometric identity. Now, we have a hint here. The trigonometric identity we'll be using is sine squared theta plus cosine squared theta is equal to 1. This part right here is equal to cosine squared theta. Just imagine if I took this over to the other side, you would end up with 1 minus sine squared theta. So therefore, we end up with the integral cosine theta d theta over sine squared theta times the square root of cosine squared theta. You'll notice that the square root of cosine squared theta is equal to cosine theta. So I'm going to simplify that in the next step, where I have cosine theta d theta. That part does not change. The bottom part will change a little bit. This now becomes simply cosine theta. And this cosine theta at the top will cancel out with the cosine in the denominator, where we are left with the integral of 1 over sine squared theta d theta. So step number 4 has been accomplished. Now for step 5, we have to integrate this. In the hint below here, we're told that the integral of cosecant squared x is equal to negative cotangent x plus c. Now, why are they telling us this? Well, remember, this is a reciprocal trigonometric function that represents 1 over sine x. That being said, this is the same thing as cosecant squared theta d theta. Now we have to integrate this, and we know the integral. This is a standard integral that you should know. And most teachers will provide that, so don't be alarmed. And the integral of this becomes negative cotangent theta plus c. So we just found the integral of this function, and it happens to be negative cotangent theta plus c. In the last step, we are asked to convert back to the original in terms of x. Now this step is usually the one that's most complicated for students. You just have to remember what you set x to at the beginning. And at the beginning, we set x to 1 times sine theta, or in other words, sine theta. What I'll do now is isolate for this theta, and that's not hard to do. Remember, on this side, we have x over 1, and I'll take the inverse of both sides. And if I take the sine inverse of both sides, I end up with simply theta. So I'm going to replace this into here. And arguably, you now have a function in terms of x. However, that doesn't mean we're done, because sine theta is like having a right triangle where this represents opposite and this represents hypotenuse. So if this is your angle, your reference angle, and this is your opposite, and your hypotenuse is 1, then if we're using cotangent for this angle, remember cotangent is the reciprocal function for tangent, right? And tangent, theta, is opposite over adjacent. So cotangent has to be the opposite of that, where you have adjacent over opposite. So to find out what this is equal to, this whole thing, we have to use this right triangle and look for the adjacent over the opposite. Now, what is the adjacent of this angle? We don't know. We do know, however, the opposite. Now, just let me write this down. Cotangent theta is equal to adjacent over opposite, so you don't get confused. Now, we have to find our adjacent for this, and to do that, we'll use the Pythagorean theorem. So we have this side here that's an unknown. I'm going to call that a. So we have a squared plus our b squared will be x squared is equal to 1 as our hypotenuse. Bring this over, 1 minus x squared, square root both sides. The adjacent is equal to the square root of 1 minus x squared. Therefore, our final answer will be this 1 minus x squared, all square rooted, over the opposite, which happens to be, in our case for this reference angle, x, plus c, and of course, the negative coming from here. So what I'll highlight here is the final answer, the integral for this function. And there you have it. That is how to integrate using inverse trigonometric substitution. Make sure you watch question 3 where we tackle an even more difficult problem than the one presented here.